Hello and welcome to the first combinations video offered by the GEM Tutoring Center. So in this video what we're going to do is talk about combinations and how order doesn't matter, and then we'll discuss the combination notation and we'll do a few practice problems. So let's start with the basic idea. So with combinations, let's give an example. We have A, B, and C, 3 letters. And the question is, how many combinations can you find of these 3 letters? So with combinations, order doesn't matter. So normally we would have, with permutations, we would have A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, and C, B, A. Okay, so these would be permutations. And they're called permutations because order matters in these, right? This is not the same as this. This is the same as not the same as this. This is not the same as that, etc. But with combinations, okay, they all mean the same thing. All of these 6 things turn into just one thing, A, B, C. With combinations, the order doesn't matter. So I can have the A here, the B here, or the C here, or I can have them in different positions, and it's still going to be the same combination, okay? So for permutations, there were 6 ways, and for combinations, in this case, there's only one way. So BAC is equivalent to this, okay? So combinations are always going to be fewer, sorry, it should be the other way around, should always be fewer than the number of permutations, because the order of the objects that we are picking does not matter. Okay, we'll explore this concept a little bit more, but for now let's talk about the combination notation. So here is the notation. It's NCR, okay, where n is the number of items in the total set and r equals the number of items in the subset. So let me write down what the formula is. It's n factorial divided by n minus r factorial times r factorial. So let's talk a little bit about the meaning of dividing by n minus r factorial and r factorial. So we have a picture here. In this picture, the oval represents the number of items, which is n. R represents the number of items we are picking, and n minus r represents the number of items that we are not picking. So, as was mentioned in the previous permutations videos, the reason why we divide by n minus r is this. So let's start with n factorial. N factorial is the total number of ways we can arrange n items when order matters, okay? So in this factor right here, there's an order mattering embedded in it, okay? And when we have n minus r factorial, that's the number of ways that we could order n minus r items when order matters. So let's just look at this section for now. Okay? So we have a total of n items. When we order all of them, the number of ways that we can order them when order matters is n factorial. N minus r factorial is the number of ways that we can order n minus r items. But in this green circle here, this is actually NPR. Okay, this is the permutation notation right here. Okay, so in the permutation notation, we divide out the items that we don't care about, which is n minus r, and we're left with the number of ways that r items can be picked from n total items. So we already explained that in a previous video, so we're not going to go much deeper into it here. But that's why we divide by n minus r, is because we don't necessarily care about those items. We're going to divide out their contribution to n factorial, and we're going to be left with the number of ways that r items can be picked from n items when order matters. Okay, but then we have this r factorial term here that's extra. It looks like extra, right? So the reason we have an r factorial here is that so from this green blob here, we got the number of ways. I'm going to write this down. The number of ways R items can be picked from n total items. That's what that green blob is, okay? The NPR. It's the number of ways R items can be picked from n total items when order matters. Okay, thanks for bearing with me as I write this. I just want it to be very clear. With R factorial, what that effectively does, this R factorial in the bottom, is it takes away the order mattering. Okay, it takes away order mattering. And the reason why is this. Do you remember the factorial method from the first permutations video? So that was the factorial by itself. A number factorial is the number of ways you can number those items when order matters. So if we just look at R factorial by itself, it's the number of ways that R items can be ordered when order matters. Remember that we want to get rid of the order mattering. We want to take it away. So what we will do is take the permutation notation and then divide it by the number of ways that we can order our items when order matters. So we're effectively getting rid of the order mattering because we're dividing it out. This n factorial is a very big number. N minus r factorial is less than that, and so is r factorial. So this is the total number of ways that something can be ordered when order matters. This is the number of ways that we don't care about, of the items that we don't care about when order matters. And this is the number of ways that we care about, but we want to get rid of the order mattering. We want to get rid of the number of ways that we can arrange this when order matters. So we're going to divide out this r factorial from the bottom, okay? So that's the meaning of those factors. Now let's do some practice problems. So if you noticed, there's no slot method for the combinations as there was for permutations. So we're going to directly use this combination notation in all the problems that we're going to solve here. Okay? So let's do this problem, number 3. Okay, let me scroll down here. It says pick 3 different letters out of the 26 letters, order does not matter. Okay, we saw this problem before when we were solving the permutations in the permutations video. We're going to solve it using combinations now because order doesn't matter. So we're picking any 3 letters out of the 26 letters, and if we pick something like ZYX, it's the same thing as XYZ. Okay, that's the only difference now. If we pick ABC, it's going to be the same thing as CBA. So in the permutations video, these were not the same, but in the combinations video, they are the same. So knowing that, we're going to use the combination notation, which is right here, to solve this problem. So let's do it. So the first question we ask ourselves is, what is n? N is the total. And in this problem, n equals 26. N is the total number of letters that we can choose from, which is 26. And we're picking 3 different letters, okay? So r is going to be equal to 3. So let's draw a little picture here. Pictures always help. This is 26, this is 3, and this is 26 minus 3, which is 23. So let's use the combination notation. So let's look at what it is again. It's n factorial divided by n minus r factorial divided by r factorial. Okay, so NCR is going to be 26C3, and that's equal to 26 factorial divided by 26 minus 3 factorial divided by 3 factorial, like that. So let's expand this out. That's going to be 26 times 25 times 24 times 23 factorial. And we're going to divide that by 23 factorial times 3 factorial. Okay? So these are going to cancel out. And remember why this is the case is because this is 23 times 22 all the way down to 1. I didn't want to write it all out, so I left it as this. And the reason why we left it this way is because it cancels out nicely with this n minus r factorial. Okay? So they cancel out. So we're left with, let's stay here, 15,600 ways, okay, divided by 6. All right, so that's equal to 2,600 ways. And remember that this is less than 26 permutation 3, which was from a previous video, where that was equal to 15,600. Okay, so this is our answer, but it's less than what we had found for the permutations, and that's because we're dividing by this extra r factorial. Okay, let's go back to the notation. We're dividing by this extra number, which is greater than 1. So a number divided by a number greater than 1 is going to be a smaller number. So NCR is always going to be less than NPR. Okay? It's always going to be less than NPR. Okay, let's do another problem. Let's say we pick 3 students out of 5 students, and order doesn't matter. All right, so let me give you an example what this would look like. Let's say you choose S1, S2, and S3. That's the same thing as S3, S1, and S2. Okay, these are the student numbers. It goes up to 5, S1, S2, S3, S4, S5. I'm just drawing the ones that we picked. If we pick S1, S2, and S3, that's the same thing as S3, S1, and S2, okay? So let's use the combination notation here. All right, so let's first figure out what n is. N is the total, so n equals 5. And r is the number that we're picking, so that's r equals 3. Now let's again just draw a little picture just to make it really clear. This is 5, this is 3, and this is 2. Okay? So let's use the combination notation. So it'll be 5 combination 3. 5 combination 3 is equal to 5 factorial over 5 minus 3, because that's n minus r, factorial, and then another r factorial here, so it's going to be 3 factorial, like that. And now let's expand this. It's going to be 5 times 4 times 3 times 2 factorial, okay? And this is going to be 2 factorial, and this is going to be 3 factorial. Again, these cancel out, okay? So we're left with 60 divided by 3 times 2 times 1, which is 6, okay? And that's going to be equal to 10. 10 ways. Remember that this is less than the 60 ways which we found in a previous permutations video, okay? So if you haven't watched the permutations videos, I would suggest watching those first, and then this comparison will make more sense. So this is less than, so 5 combination, let me do this again. So 5 combination 3 is going to be less than 5 permutation 3. Okay, this is 5 permutation 3, this is 5 combination 3. So this is less than this. And it's less because order doesn't matter here, so you can have, again, S1, S2, S3 will equal S3, S1, S2, whereas in permutations, these are not the same. So there's more number of ways in permutations than there is in combinations. Okay, now let's talk a little bit about the calculator, okay, and how you would use that to find the combinations. So let's look at that. Here's the calculator. Okay, so you have on your calculator an NCR key. It looks like this. So what you will do is you enter N, then you hit NCR, and your key may not look exactly like this. You might just have a C with something like this or something like that. But generally it's like this, NCR. Okay, so you'll enter N, then you'll hit NCR, the NCR key, and you might get a symbol like this that says C, or it'll just say NCR, okay, in your calculator display. Then you hit enter. No, you don't hit enter. You enter R, and then you hit equals. Okay, so you enter N, you hit NCR, you enter R, and then you hit equals, and then you'll get your answer. Okay. So we'll give an example of this in the next video, but just a few comments right now. So we use the calculator when R is large and when R is close to N. And the reason why is this. So this is NCR. That's equal to this, right? So when r is close to n, let's say n is 25, okay? And if r is close to n, like r is, I don't know, r is say 23, okay? You're gonna have 2 factorial here and 23 factorial here. So in this situation, it's nice because you'll get 25 times 24 times 23 factorial like this, and that will cancel with this, right? So you'll be left with this divided by 2 factorial. So in this situation, for combinations, it may not be so critical that you use the calculator to solve it, because you have this factor here which cancels out with a big factor here. But for permutations, at least, when r is large and is close to n, you should use the permutation key on your calculator. And if you want to learn more about that, you can check out some of the previous videos that we did. Okay? For combinations, this is true, but you're kind of saved by this factor here, which cancels with this. In permutations, you don't have this, and you're left with a very long multiplication you have to enter into your calculator. But in combinations, you have this extra r factor, which does cancel with something up here. So you're left, so it's not actually so bad. You can actually do hand calculations with the combination permutation much more easily than if you had to do it with permutations. Okay? So that's this video, and keep an eye out for the next one, combinations part 2. And please do hit subscribe if you want to learn more about when videos are released, and turn on your notifications. And please stay tuned for the next one. Thanks.